I don't think I've had more than 6 hours of sleep in a really long time.
Okay, so the last section we're going to do in this chapter goes over geometric sequences and series. We just talked about arithmetic last week. That was when you were adding or subtracting the same number over and over and over again. This is either multiplying or dividing by the same number
I'm so good at
over and
doing
over.
that.
Geometric is
What?
I'm so good at doing that.
Multiplying over and over?
Yes.
Oh, well, great.
In arithmetic is plus or minus.
Your calculator is definitely going to be helpful today. So we're going to talk about how to find the common ratio. Like last week when we did the arithmetic, we talked about finding common difference. That was like how much it was increasing or decreasing by. In a geometric, we don't call it difference, we call it ratio. Because since you're multiplying or dividing, it's a little bit different. We'll talk about how to find terms of a geometric sequence, how to use a formula to write the geometric sequence, how to find the sum. All of the same things that we did with the arithmetic, we're going to now talk about this one. So a geometric sequence, remember, is when you are multiplying, or sometimes you can think of it as division by the same number. So a lot of times it'll be like you're multiplying by 2 every time, or you're multiplying by a half every time. But when you're dealing with the fractions, you can think about multiplying by a fraction, or you could think about dividing by a number as well. When you have a geometric sequence, the formula for this one looks a little different. Last week when we talked about the arithmetic, I'll just write that up here on the board behind me. The arithmetic was a little different because you started with the first term, like A1, and then it was plus your difference times n minus 1. That was our arithmetic sequence that we talked about. You can see how this one's a little bit different. Okay, it says an is equal to a1, so that still is the same, like your first term's going to show up. But then that r that's next to it, that's the ratio. So they're dividing by 2 or multiplying by 2, and then it's raised to n minus 1. So all of these pieces down here tell you what all those symbols in that formula stand for. A1 is your first term. N would be the number of terms that you're trying to find, or the number of terms that are in your sequence. R is the ratio between the terms. And then to find your ratio, all you do is divide the second term in your sequence by the first term in your sequence. Really, you could do that with any 2 terms in your sequence, but you want to make sure that you're always taking the later term in the sequence divided by the previous term. And they have to be following each other. You can't just pick any random 2 that you want from your sequence and divide. They have to be right next to each other in the sequence in order to find the common ratio. So let's do an example here. This one's worked out for us, but you can see they want us to find the next 2 terms of this sequence, 2, 8, 32, and then it goes ... First thing I would do is find your ratio. So you take the first 2 terms, which are the 2 and the 8, to help you find your ratio. And you're just going to divide 8 by 2, which is 4. So that means that the common ratio is 4. They're multiplying by a 4 every time to get a new term. 2 times 4 is 8. 8 times 4 is 32. So then we would continue that pattern if we wanted to find the next couple of terms. So the next one would be to take the 32, the last term there, times 4. That's what they're doing here. And they get 128. Then you take that 128, because that would be the next one, like up here if I added it on. Then you take 128 times 4, and you get this 512, and that would be the next term in the sequence. Okay, so let's do one as a practice problem here. What do I need to do to find my common ratio?
You gotta divide.
Divide what by what?
You can divide 81 by 27, or you can divide 27 by 9. Well, 27 divided by
You want to go the other way, though.
Go by 3.
You want to go like this. You want to do 27 over 81. You always do the second term divided by the previous term. Because otherwise you'd get 3, and you're not multiplying by 3 each time. What is that reduced to? What is 27 over 81 reduced to?
1/3.
1/3. So most of the time when they talk about the ratio, they're going to talk about it in terms of multiplication. However, to us, could we think of this as dividing by 3? Yes. But that's not the same as if you did 81 over 27, you would get 3. You're not multiplying by 3, though. You're multiplying by 1/3. Or you're thinking you're dividing by 3. That's why they usually always talk about it in terms of multiplication, because it gets confusing to try to go back and forth between the 2. So we're multiplying by a third every time, or you can think I'm taking all the numbers divided by 3. 81 divided by 3 is 27. 27 divided by 3 is 9. So what would be the next term? What's 9 times a third, or 9 divided by 3? 3, and then 1. So those would be your next two terms.
Can you divide 1 by 3?
You could, if you wanted to keep going, then it would be a third. And then you could continue. Yeah, so you'd start to get fractions or
Are
decimals.
you gonna make us do that on the test?
I mean, maybe.
Why?
I don't know. See how I feel.
Does she hate me?
Fractions happen in math. It's just part of the deal. I know.
Yeah, I think.
Okay, next page.
Do you know his name?
Probably whoever created pizza.
It was probably a man.
Whoever created pizza created fractions. I don't know, probably some Italian guy.
Or pie. You guys love pie.
Yeah, or pie. Okay, so let's talk about how you would write the equation of a geometric sequence, or how you would find not necessarily the next two terms, but like any term I wanted down the line.
What was the first time math was used?
7 pages.
Okay,
Oh, no.
we're gonna write this next one. They want us to write the 10th term of the geometric sequence. So my sequence here starts as 4, 12, 36. So I'm using this to help me. I need to start by finding my common ratio, which we just talked about. You take the second term, which is a 12, divided by the term right before it, which is a 4. So 12 divided by 4 is 3. So this is our common ratio. So it looks like they're multiplying by 3 every time to move up. Now, to find the 10th term, could I multiply by 3 a whole bunch of times and count out to 10? Yes, I could. But there might be a faster way, especially if they wanted like the 100th term. That would be way down the line. I don't want to have to sit there on my calculator and go times 3 times 3 times 3 100 times. Okay, so this formula that we saw at the beginning of class, this one here, is what we can use. Remember, A1 stands for the first term of your sequence, which is the 4. So this 4 goes in for A1. We just found our common ratio to be a 3. So that goes in for R. And then the N minus 1 piece, all you have to do is plug in N. N is going to represent the term they're wanting you to find. They're wanting me to find the 10th term for this problem. So 10 would be your N. So they plug that in here. Right here's them plugging it in. 4 is that first term times 3, which is the common ratio. It's raised to the 9th power because it's N minus 1. So 10 minus 1 is 9. And then you just type this into your calculator and you get this answer. Now, with these geometric ratios or sequences, your numbers are going to start to get very large or very small fast because you're multiplying or you're dividing by the same number over and over. That is going to be exponentially quicker than if you were adding or subtracting. So it's not abnormal for us to get really large numbers or really small numbers here. So let's do an example. We're still using this formula. What are we going to put in for A1?
125.
Oh, wait, no, sorry.
20 goes in for what, though? The N. And so 125.
Times
Now I need to find my ratio. How do I do that?
would be negative 50 over 125.
Yep. Which reduces to what? Use your calculator if you need to.
1 over...
I don't think negative 1. I don't think 50 can go into 125. What'd you say, Elisha? 2/5. So negative 2/5 would be my common ratio. So over here, negative 2/5 to the what power? 19, because it's always N minus 1. So 20 minus 1 is 19. Okay, then I would just plug this in. If you're going to type it in all as one sentence, make sure you're using parentheses and watch your signs. Make sure there's a negative in front of that fraction or it will not do it correctly for you. What do you get here? Should be a small number.
You didn't add a negative. You just add a negative at the end.
It depends on what the exponent is. Like in this case, because it's an odd power, it's going to be a negative answer.
Negative
If it was a positive power, it would end up canceling that negative out. How many zeros is it?
4, 3, 6. Looks like 5. 1, 2, 3, 4, 5.
3 what? 3, 4?
3 zeros, 3, 4.
Wait.
Like 5 zeros, 3, 4, 3, 6.
Okay.
3, 4,
Really small. Sometimes when you have small numbers like this, they may start to write their answers in scientific notation, or if you start to get really small answers on your calculator will start putting it in scientific notation for you. Remember to do that. You just move your decimal 1, 2, 3, 4, 5, 6 times.
Do I have to write it inside?
You don't have to, but sometimes your calculator will do it automatically.
Do I need to undo it then?
So this could be written like this, to the -6 power. If it was dealing with something really small. How most calculators will do that is at the very end of the number, if it's in scientific notation, it'll say like E, and then it'll give you a number. That would be telling you what the exponent is that the 10 is raised to. So some calculators will do that, especially if they start to get really tiny. They won't show you the full decimal because they only have so much screen space to do that. So they'll start just putting it in that scientific notation form. Questions on that? We doing okay so far?
I want to go eat that goldfish.
Okay, let's talk about how to find the sum now. So remember, the sum of a sequence is when you find all the terms and you're adding them all up. Now, we don't always have to find all the terms, though. So they give us two cases of, depending on what kind of information they give you, how you could maybe find the sum. The first situation is if they give you A1, so the first term, and N. N would be the number of terms that they want you to find. Okay, if you have that piece of information, you're going to use this formula, the one on the top there. In that formula, you see A1 show up twice. We still have our common ratio in there. And then N is just the number of terms that you're trying to find. So they would tell you N would equal 10 or N would equal 15. The other case is if they give you the first and the last term. So they tell you where the sequence starts and they tell you where the sequence ends, and they would want you to find the sum of all of those. So this formula looks a little bit different. It's the second one here on your chart. Some of it looks the same, like they have an A1 on top to start it off and a 1 on the bottom to start it off. There's subtraction signs on both top and bottom. But some of the other elements start to change a little bit depending on what they give you. We're going to do examples of each kind, starting with the first situation. If they give you A1, so the first term, and they give you N, we're going to start with that case. So find the sum given. They're giving me some information here. A1 is 16. Common ratio is 1/2. And N is 7. So they're giving us all of that. They want us to plug it into this first formula. So they're using this one up here. So you can kind of see where they're putting these numbers at. In for A1, they put the 16. They did that twice. 16 is here and here for the A1 pieces. Common ratio was 1/2. So that went into the parentheses. Raised to the N power, which they're saying is 7. And then all over 1 minus 1/2. So they just kind of plug all those pieces in, and then you just start working with the numbers on your calculator. So they simplified the top a little bit here. They did the 16 times the 1/2 to the 7th power, and they got 16 minus 0.125 all over 0.5. Can you guys finish this, though? Can you do this and tell me what you get? Someone type that into your calculator and tell me what you get.
43 over 16?
Mm-mm.
That's
Oh, I have a calculator. I got you. 31.75.
Good, 31.75. Okay, so you guys try one on your own. Same formula. I'm just going to write that formula out again here. Okay, you plug in the pieces and try to figure this one out.
I think I should just make, you should staple these like a book.
Yeah.
how do you do the S?
You don't need the
You
S.
don't need the S. So.
You just need to work on the fraction part.
Oh.
The S just stands for the sum, so that's just like what the answer is.
Earlier, you were like, you can go to the calculator and you can just press a button and it'll. I couldn't find the button. But I can't
For the
remember.
like factorial, for the exclamation point,
Yeah, I couldn't find it.
it's under the PRB button. So the PRB button is diagonal from the second key.
Oh.
It'll be in
N
there.
over D.
Okay, let's start plugging in. What'd you guys put in for the A1?
4 minus 4 times negative 1/2 to the 7th power.
Not the 7th power.
Wait, what?
It's raised to the n, so to the 8th power. Over 1 minus negative 1/2. Watch your signs on this one here. There's a lot of negatives floating around there. Anyone have an answer? What? What'd you say? Nope.
I had it all.
What'd you say? Point what? Oh. 2.6. Okay. Okay. Sorry, I just heard you say 0.6, and I was like, no. It doesn't round to that, though. Almost does. Okay.
They made 6, 7 chicken nuggets.
Questions on that?
What?
They did.
Did they?
Made 6, 7 chicken nuggets.
Today's my middle child's 7th birthday, and he's having a 6 party
You
tonight.
should go get 6, 7 chicken nuggets. Yeah.
Oh.
You can go make him chicken nuggets for dinner.
He did not request 6, 7 chicken nuggets for tonight. I will. He's got a cake topper that says, I was 6, now I'm 7.
Oh,
So
did you make t-shirts? I know a lot of people be doing that.
not for this one, no. Mm-mm. Okay, now let's do the other side of it, the other formula, which is when they give you the very first term and they give you the last term. So notice that this sum looks a little different. They have 3 plus 6 plus 12 plus some stuff missing there in the middle, and then they end with the 3072. I don't know how many terms are in here. I don't know how long it took them to get up to that 3072. So we do need to calculate the ratio, which we've done before. We take the second term divided by the first term. So 6 divided by 3, which is the 2. That's where they got this from. The second formula that we haven't talked about yet is right here. And so it looks a little different. We still are going to plug in our A1, which is a 3. We're still going to plug in our A sub n, which is 3072. Our ratio is a 2 here, and then it's all over 1 minus r, so 1 minus 2. So they did all of that. Again, they put all of this into a calculator, and they got 6,141. So all those numbers from the sequence added together would get me to that. So let's do this for the second one here. Using the same formula here, we're still using this. What do I put in for A1?
A1's negative 15.
Negative 15.
Negative 15 minus.
What's the last term? 480.
480 times negative 2, because 30 divided by negative 15 is negative 2.
Okay.
And then it's all over 1 minus 2, so 1 plus 2.
Okay, so just to clarify, he said to find that r, we took 30 divided by that negative 15. So that's negative 2. That's where this number's coming from, here and there. Okay, so go to your calculator, type all that in. Tell me what you get.
315.
315. All right.
1, 2, 3.
Questions?
4 more pages.
We doing okay so far?
3.5 pages, actually. One more problem on the last page.
I'm done locking in.
Okay.
We have like 10 minutes left.
We have 18 minutes left.
Well,
Let's keep going. Okay. We've seen this before. Summation notation. It's the same thing as arithmetic as far as what all the terms mean. So remember, the bottom piece here tells you your lower limit. The number at the top up here tells you your upper limit. The formula looks a little different that follows the summation because we are dealing now with a geometric sequence, not arithmetic. So you have your first term, A1, times the ratio raised to the n minus 1 power. Okay, so they might give you something that looks like this first example. Our lower limit is 5. Our upper limit is 8. And then 1/2 would represent your A1. And then 3 would be your common ratio. And then S minus 1 here. So they're writing this all down. They're kind of separating it out for you. To find A1, we need to plug in a couple of things. So most of this just kind of comes down and repeats itself. The only thing that they did change is that instead of having an S, you start by putting in your lower limit, which is the 5. So they're saying S is 5 originally. So they plugged that in and then they just evaluated this. So it became 1/2 times 3 to the 4th power, which is 1/2 times 81. So they got 40.5. That's the first term. Then to find your n, like the number of terms that are in the sequence, we did this with arithmetic sequences as well. You take the upper limit minus the lower, so 8 minus 5, but then remember you have to plus 1 to make up for the one that you didn't count when you began counting. So that's where this 4 comes from. And then the common ratio is 3. So we have our A1 is 40.5. We have our n, which is 4, and we have our ratio. Since you have the first term and you have n, going back to those formulas from the previous page where we had 2 choices, we want to use that first one because that gives you A1 and it gives you the n. And then you just plug it in accordingly here. So all of this just comes from that formula that we worked through on the previous page, and we end up with 1620 for our final answer. So as far as using that formula, it's no different. You're just looking at it written. Instead of giving you the series written out or maybe just telling you, here's A1, here's your ratio, here's N, you have to find some of that information first and then plug it in. Okay, so let's do another one here. All right, so let's talk about what A1 would be. So A1 would be if we evaluate this summation here at 81 times 1/3 raised to the 1 minus 1, because you plug in your lower limit.
It's actually going to cancel out to 1, and it's going to be just 81.
So it's going to be 81. Anything raised to the 0 power is just 1. So 1/3 raised to that 0 exponent becomes a 1 times 81 is 1. How many terms are in this? 7, because it's 7 minus 1 plus 1. So there's 7 terms. And then what's the common ratio according to the summation?
One third.
1/3. This is your R right here. Whatever's raised to that exponent is your R. So now we're going to plug all this into our equation. So we're still using, that first one. So it's going to be 81 minus 81 times the R raised to the n power, which is 7, all over 1 minus 1/3. Again, that came from the previous page. I'm not just pulling that out of nowhere. That came from the formula that we just talked about on the previous page. So do that. Go ahead and put that into your calculator. Tell me what you get. No, much bigger.
23.
Still bigger.
100.
100 something. 120.
Repeating.
There you go. You were really close there. 121.4 repeating.
I would actually be close to that if anyone. Oh, you said 129. What did you say? 100. Oh.
Okay, we want to keep going?
Yeah.
Let's get this done. 1, 2, 3.
Okay, the last kind of area in this is applying what we've done to some of these situations that you might run into. This first one is talking about how to find the value of an annuity. An annuity is like an investment for like retirement or something like that. Okay,
So it's a retirement account, basically.
kind of, but it's something that you would do on your own. It's not necessarily something that would be provided for you from like an employer.
Well, yeah, it's your own retirement. It's basically
Yes, it's like you putting money aside for yourself so you can retire someday. So in the formula, this formula is a little bit of a monster here because there's a lot of pieces that you have to plug in. Capital P would stand for your deposit that you're putting in every month. So however much you're putting towards that. An annuity could also be like if you're putting money aside for like a kid's like educational savings account. Like every month we put money in for all 3 of our children so that eventually when they go to college, they'll have money to use for that. So that would be another time that you would maybe use something like this. So P would be the amount of money that you put in every single month. R would be your rate. So the percentage of like interest that you're earning on it. N would be the number of times compounded per year. So this could change depending on what kind of annuity you have, whether it compounds monthly or maybe only twice a year or maybe only one time a year. And then T is usually time in years. So we started ours like right when our kids were born. So it'll be done for 18 years. And then once they turn 18, they can access that money and use it for college. Okay. So other times that this would be used as investments for retiring, or if you're trying to save up for something else, like you could use an annuity to do that. So for example, at age 30, okay, you decide you're going to start saving some money, extra money maybe for retirement. You're going to decide to deposit $100 at the end of each month into an IRA that pays 9.5%, compounded monthly. How much will you have from the IRA when you retire at age 65? So this is 35 years that this money, you're going to deposit $1,000 or $100 every month into this account.
And we screwed up that one a little bit.
Yeah, that should be
65 minus 30, or minus 30 actually equals.
Yeah, that should be a 30, not 35. That's a typo right there.
Well, then 60 should
There.
be 65.
Should be 60 minus 30. Yeah, 65.
It's 30.
No, it's still 35. The typo's there. It should be 65 minus 30. They had the numbers switched. Yeah. I don't know why they did that. Okay, so you're putting in 100. That's your P. Your rate, 9.5%. You have to write this as a decimal. We've done this before, or problems like this with a percentage. So that would be 0.095. N would be how many times it's compounded. It says compounded monthly. There's 12 months in a year. So that would be 12 times in a year. And then it's 35 years total because you started at age 30. You're stopping at age 65 because you're going to retire. So they're plugging this all into the formula here. They put in the principal amount, they put in the rate, they put in the times that it's being compounded, and then you just type it all into your calculator. Slowly work maybe through this one. By the time that you're 65, you'll have this much money in that account. $333,946. Okay, that's a good amount of money, but is that enough to probably retire on? No, probably not. So, but this would be if you just did $100 a month. Let's say you did $500 a month. Okay. Or let's say you decide I'm going to do this when I start becoming 20 years old versus 30. Okay. If you start sooner, you'll have more money as well. Okay. So then if you wanted to figure out interest that you earned as well, you could do that too by just looking at some of the pieces here. So 100 is the amount you're putting in. 12 is the times it's been compounded a year, and then 35 years. So you invested yourself $42,000 because every month you did $100. So you'd have to actually subtract those to get your actual earnings from just the account. The rest of that was like by you putting money in. Okay, so underneath that it says same problem, but let's say we start 5 years earlier. We're starting at year 25 instead of year 30.
So it'll be 40 years to invest.
So 40 years. So a lot of this is going to look the same. It's still going to be 100 times 1 plus 0.095 all over 12. None of that has changed. Okay, raise now though to the 12 times 40 because we're starting 5 years earlier now. And then this is minus 1 all over 0.095 divided by 12. If I were you and you're typing this in on your calculator, do not try to do this all in one step. You will probably make a mistake if you try to do that.
Hold up.
I'm not telling you you're bound to fail. I'm just saying it's possible. You can go ahead and try it, Memphis.
Hold up.
Try and type it all
Hold
in
my
at one
beer. I
time.
will try.
Make sure you put in like
Just hold my
parentheses
beer.
and everything.
Brackets.
Yeah, you'll have to just
So
use multiple
basically,
parentheses.
Oh,
Multiple
Okay.
parentheses.
I got it.
Okay, go ahead and try and see what you can come up with here. We'll see if you get it.
Memphis.
1 plus. I heard my name.
We'll continue doing the
What?
equation. We're waiting for the
I already
equation.
did it wrong.
It should be higher because we started 5 years earlier.
It's lower, and you're like, what?
Okay, were we just?
What'd you say?
6,000. No wait.
Are we just pointing
Can
this
you
out
just-
of our?
Add 12,
639,429.
36 times.
Nope, it's not that.
Yo,
So
I
one
actually think
didn't-
I got it.
Let's
What?
see.
You think you got it, Danny?
Hold on. I'm doing the bottom
Jimmy?
part.
Okay.
What'd you say?
Danny?
I said Danny. What's Danny?
1.047.
No. No.
All over.
Well, it's the times 10 to the 23rd power as well.
No.
All over 12. Okay, let's see. 543,629.
Memphis got it.
I told you I could do it. I did.
Oh, I didn't.
Should have been Memphis.
What the frick, man?
I didn't put the
Oh,
zero.
I'm running out of room here. Okay, this should be 543,629.19.
No, you're
Okay.
lying.
I got the 29 right.
You got the 29 right. Now, let's think about how much you actually earned because you still had to put in money to make this money. It wasn't just handed to you. You're not just getting, when you turn 65, the government's not just going to say, here's $500,000.
Happy 65th birthday.
Okay. So let's think about how much we actually earned here.
Wait, do you get interest?
In this? Yeah.
Okay,
No, it was
minus
just
that
accounted
first
for.
number.
Yes. So we're just wanting to know what the interest was. So we started this at age 25 instead. So to find just what I had to put in, I did this $100 every month, still 12 months a year, but this time I did it for 40 years. So how much money did I put in of my own?
48,000.
48,000. Okay. So
And it
over 40 years, that's $48,000 total that we put in. If you subtract that from how much you got in your account,
So you did like.
how much did you actually earn?
530,629.
Nope.
495.
There you go.
495,629 point. This is about half a mil.
This is like a money hack.
What?
This is like money hack.
Well, I mean, it's investments, but you have to be putting in the money every single month. I mean, you could. Most people can. Some people choose not to.
Well, sometimes I need the money.
Make another account.
Okay, we're going to stop here for today.
No.